We have with us Dr. Richa. She's the program manager with CSC Solid Waste Management and Circular Economy. Thank you so much for joining us, Richa. We are here to discuss a very important topic, and yet that is not discussed enough. That is methane emissions from the dump site. Richa, my first question to you would be, why is it a matter of concern, methane emissions from dump site?
Firstly, thank you, Sukanya, for having me and inviting me for this very important session that we are having today. I think we all aware about it. Landfills are considered as the third largest emitter of methane, after oil and gas sector and as agriculture sector. And if we talk about figures, globally in 2016, there was emission of 1.6 billion dioxide equivalents because of the disposal of solid waste into landfills. And this is expected to reach 2.6 billion tons of carbon dioxide equivalents. In future, I think 2050, we will reach 6 billion tons of carbon dioxide equivalents. So this is very, very alarming. And the reported data by World Bank. And if you look at how it is produced from the landfill, it's important for us to understand that one mixed waste in most of the economies, this is what is happening, is the dump sites or the scientifically constructed landfills. The biodegradable fraction of the waste is something that undergoes a sequence of complex chemical reactions. And a lot of methane form in that process, which gets escaped environment. So many of the developing economies are still not have scientific constructed landfill sites where they don't have any mechanism to the methane gas, capture the methane gas and use it for applications. And if about methane, we all know that it's a greenhouse gas whose atmospheric concentration has doubled over the 2 centuries, primarily because of the anthropogenic activities, including the disposal of solid waste into the landfills. And if you look at its global warming potential, which is its ability to treat in the environment, 28 times more than carbon dioxide. And in addition, methane something which potentially contribute in the formation of tropospheric, which is also called ground-level ozone. And this as a very hazardous air pollutant, also greenhouse gas, and this is causing premature deaths globally every year. So it's very important to talk about this agenda. And I think having said that, it's very important for us to understand methane it's a short-lived climate pollutant, which means if you compare its atmospheric span, it is much less than your carbon dioxide. It's approximately 3 years, which I think it offers an opportunity, and it's an opportunity for us to make sure, that we are mitigating, if we are reducing the emissions, to see the impact in the near future. And we can do that if at all minimizing the waste, the source itself. We are adopting segregation, we are channelizing the biodegradable organics to the recycling fees, and we are making sure that such emissions not happening in the future.
So CSE recently released, which was authored by you, which was about the analysis of the current scenario methane emission from the waste. What, according to you, the major recommendations that could be the mitigating strategies to reduce methane from the solid waste sector?
Actually, this is the report that we are talking about, which is methane emission from open dump sites in area estimation and mitigation strategies, which can be downloaded from CSE website. And I think this is basically a study which was done in order to understand what different models which are available to estimate methane, what are the limitations of those models, the input data that we require in order to correctly estimate the methane at open dump sites in the country. And also we talked about the mitigation strategies. There are many recommendations made in the report, but I would like to highlight 3 major recommendations here. First and foremost is the phasing up the disposal of biodegradable organics. So as I mentioned, degradable organics, if it is reaching your dump site, can act as a culprit, because this is the one which is causing a lot of methane generation. But if you're channelizing it to, a recycling facility, a composting facility, or biomethanation plant, you can capture that methane, which can as a fuel. So, landfill gas has a similar composition biogas. But once the landfill, it becomes a waste, and also it is causing global warming. But if you are diverting it, it can be used for various gainful applications. So the first and the foremost thing is to how the disposal of biodegradable organ in the landfill, especially in case of our landfills with scientifically constructed and not having any mechanism to trap the methane, it becomes really practically impossible. Once it is there, you to do something about sucking the methane later afterwards. So that is the first recommendation that we have made, that organic waste should be treated as a resource, can be used for various gainful applications, should not up into our dump site or the landfills. The second most important recommendation is the scientific treatment of, now if you are phasing out the dumping of this thing, biodegradable waste, what should be done? So we need to go for strategies like composting, biomethane, and bio-CNG is all there, where trying to produce some resources of the waste. And so if I have to give a proxy estimate, let's say if we are diverting 1 ton of biodegradable organics from reaching the dump site, 1 biodegradable organics can produce around almost equivalent to 80 to 100 cubic meters of biogas. Now, 60% of this is methane. So I'm diverting that much, actually I'm saving that much methane. So if you do a rough estimation, it will be equivalent to 42 kilograms methane. That translates to a 1200 kilos of carbon dioxide equivalents, which is a huge number. Right. So if you do a similar kind of mathematical entire quantum of which is generated in India, that will be like huge. And that much amount of methane we are actually, minimizing from reaching the atmosphere. Yeah. And third, I think most important recommendation is to remediate the existing legacy waste dumps. So legacy waste dump site are the dump sites that we are seeing around us, but at the same also receiving the fresh waste. So if I compare the main emission potential which is coming out from a legacy waste or fresh waste, of course the legacy waste which is more than a year old will have less potential to generate methane in comparison to the fresh waste which is dumped. And in our case, most of the dump sites that we are seeing are still operational nature, and they end up receiving a lot of waste. So I think remediating these sites are extremely important so that we can get rid of this kind of mixed waste dumping in our landfills. So yeah.
Richa, final question to you. What are the challenges that we are facing in estimating methane emissions from the dump site?
This is a very important question, and that's why we need collaboration, policymakers, researchers, and policy think tanks like ours, where we're trying to bridge the gap and understanding that what is wrong with the models being developed and where is the problem. So through our study, what we have seen is, we have so many models, so it can be classified into experimental and theoretical method. We have so many models or theoretical models for estimating methane, such as the default method, which is the most conventional one and the most oldest one. We have LENGEM model, which is developed by CPA. We have IPCC default method. We have modified triangular method. All of these, the estimates by using methane estimates by these models depends really on how is quality of the input data and what are the input, like how much is the generation in the country, how much of it is actually biodegradable in nature, how much biodegradable is actually reaching the sites. Right. So these are the different and critical data that we don't have in our country right now. So in order to get more precise value, we need to have very consistent, reliable data set, in the waste sector. Also, the default value is not updated as per, our country specific climate. So that is also one of the limitations.
Can you explain that a little bit?
So basically, I think every natural material has a tendency to decompose or degrade, right, and it will degrade at a certain rate. Okay. Now it also depends on certain factors like the presence of oxygen, the presence of moisture, the presence of air, things like that. Yeah. Now every country has its own climatic condition. And, the waste get decomposed here in our landfills different from the way it is getting disposed of or degrade in a US landfill. So we need to have such default values which are specific to our conditions. So this is what I was trying to.
Thank you so much, Richa. Thank you so much for joining us. We'll be back soon with a live chat soon. Thanks again.
Thank you, everyone. Thanks, Sukanya.